So today we are going to discuss about the problems related to the exercise 8.3 from trigonometry, that is all about proving some important equations, that is exercise 8.3. The first problem from fourth main. So I'm going to concentrate on the fourth main first problem, where we have to prove that cosecant theta minus cot theta whole square is equal to 1 minus cos theta divided by 1 plus cos theta. This is the fourth main first problem. So LHS. So I'm not going to rewrite the LHS. The basic things to be required to solve the exercise 8.3 is we should have a proper knowledge of trigonometric ratios and all the three important identities. Okay. So before you start solving the exercise problems, 8.3 exercise problem, recap it. Okay. Otherwise even we cannot start it, because see, what is cosecant theta? How can I write cosecant theta? Cosecant theta can be written as 1 divided by sin theta. Cot theta can be written as cos theta by sin theta. Some students ask this question, sir, why can't we expand cosecant theta minus cot theta? That can also be done. So we can prove, we can get the RHS in 2 to 3 ways. Okay, but we will approach that way which is easier for us. Okay. So simply we in RHS we got something in terms of cos theta. So better to write everything in terms of sin and cos, and later on finally convert that into cos only. That will be more easier. Now the LHS is sorry LHS 1 by sin theta minus cos theta by sin theta. So sin theta is the uh, so you will get sin theta minus cos theta, right? Sorry, 1 minus cos theta, and don't forget the square. So let me explain this again. So I kept it to the power as it is. So always try to solve the terms which are in the bracket first. Later on start dealing with the terms or else the expression which are outside the bracket. The power 2 which is outside the bracket. So keep it as it is. First simplify the things which are in the bracket. That is 1 by sin theta minus cos theta divided by sin theta. Okay. So LHS will be, so sin theta I took LCM. So sin theta get cancelled. So 1 we left up with 1. So again sin theta get cancelled with each other. So cos theta as it is. So if you have confusions in addition, subtraction of fractions, recap it like 1 by 2 minus 3 by 4, take LCM and solve it, and again you will get a better idea. So now start expanding the 1 minus cos theta whole square divided by sin theta whole square. So 1 minus cos theta whole square divided by sin theta whole square. This is nothing but 1 minus cos theta into 1 minus cos theta. So sin theta whole square is nothing but, always remember, this will become sin square theta. Sin square theta. So 1 minus cos theta, 1 minus cos theta. So I'm not expanding 1 minus cos theta like by using a minus b whole square, because finally I want something 1 minus cos theta in numerator. So I'm trying to keep the 1 minus cos theta as it is without disturbing it. Okay. So sin square theta can be written as, this sin square theta can be written as, we know the identity, 1 minus cos square theta, because sin square theta plus cos square theta is equal to 1. So sin square theta can be written as 1 minus cos square theta. Got it? Now this is nothing but 1 minus cos theta into, sorry, 1 minus cos theta into 1 minus cos theta whole divided by 1 minus cos square theta. 1 minus cos square theta can be written as 1 plus cos theta into 1 minus cos theta. How? Explain it again. Let me explain it. 1 minus cos square theta, 1 minus cos square theta. This is nothing but 1 square minus cos square theta. Okay. So this is in the format of what? A square minus b square. So a square minus b square is a plus b into a minus b, where a is equal to 1, b is equal to cos theta. Now a square minus b square cos theta will become what? So a plus b cos theta into a minus b cos theta. Okay, all these things are basics. If you are still getting confused, watch it again slowly. Got it? So now we have, finally, let me get back to the problem. 1 minus cos theta, 1 minus cos theta will get cancelled with each other. So I left up with 1 minus cos theta divided by 1 plus cos theta. This is nothing but, see, xy divided by xyz. Everything is in product format, right? 1 minus cos theta multiplied with 1 minus cos theta. 1 plus cos theta multiplied with 1 minus cos. So it is in product format. So I can cancel x and x, y and y. And I left up with 1 by z only. But in case x plus y and x minus y is there, don't cancel x and x like this, y and y like this, because it is in addition format. Okay, so there is a difference between xy divided by xyz, xy divided by x plus y plus z. So don't cancel x and x, y here, y and y here. But if it would be in product format, so x and x get cancelled with each other, y and y. So I will left up in 1 by z. This is again, everything is basic only. So RHS is nothing but 1 minus cos theta divided by 1 plus cos theta. Now let me take the next problem. The second problem from this exercise, that is, prove that cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A is equal to 2 secant A. So let me expand the LHS. So 1 plus, so in LHS we have 1 plus sin A. LCM, what is the LCM of the LHS? 1 plus sin A into cos A. Now what should I multiply with cos A? So that is nothing but 1 plus sin A, 1 plus sin A, common factor. So cos A has to multiply with cos A, plus again here if you look into this expression, cos A common over here. So 1 plus sin A has to multiply with 1 plus sin A only. If you are getting confused, simply take one simple expression like 2 by 3 plus 4 by 7, take LCM and solve it, and easily you can understand that what exactly I am doing. It's all about addition of fraction by taking LCM. So 1 plus sin A into cos A, let me keep that as it is. Simply cos A into cos A will become cos square A multiplication plus 1 plus sin A into 1 plus sin A, 1 plus sin A into 1 plus sin A, 1 plus sin A whole square. Okay, so 1 plus sin A, I'm keeping the denominator as it is. Fine. So LHS is cos square A plus 1 plus sin square A plus 2 sin A. I'm applying the formula A plus B whole square over here. So A square plus B square plus 2AB, where A is equal to 1 and B is equal to sin A. So that 1 plus sin A whole square is equal to 1 plus sin square A plus 2 into 1 into sin A, that is 2 sin A. Okay, so denominator is, that's why I wrote 1 plus sin A whole square as 1 plus sin square A plus 2 sin A. Again, this is all about the basics to be remembered well. So denominator is 1 plus sin A into cos A. Let me keep the denominator as it is, 1 plus sin A into cos A. Okay, so see, we know that cos square A plus sin square A is 1, and this one, let me keep it as it is. So 2 sin A, again let me keep it as it is. So 1 plus sin A into cos A. So 1 plus 1 will become 2. 2 plus 2 sin A. Okay, so into 1 plus sin A. Solving trigonometric problem requires lot of patience. We have to solve each and every step properly. You'll get a marks for each and every step. So always remember that each and every proper step, not for every step. Okay. So don't get confused with that. If you write more steps, you'll get more marks. It's basically 3 marks or 4 marks problems. You may get half marks for each and every proper step. So 1 plus na. So I took 2 out of the uh, bracket. So I left up with 2 into 1 plus sin a. So 1 plus sin a, 1 plus sin a will get cancelled with each other. 2 divided by cos a. This is nothing but 2 secant a. Okay. Now the third problem is a bit lengthy problem. So I will take it afterwards. So let's because we have to start from medium, average, and all those things. That is one of the toughest problem in the exercise. Third one is that. That's why I'm taking the fourth one. That is nothing but this is again medium level problem. So once you become perfect with the medium and easy level problem, then we can start solving the difficult one also very easily. So gaining confidence is very important. So LHS is 1 plus secant A divided by secant A, as we can see it over here. As I told you, the first step is, okay, secant A is 1 by cos A. Start applying the known ratios. That is the first thing which has to done. Okay. Start applying the known ratios and identities. Especially in this, all the first step is, if tan is there, okay, sine by cos. Cot is there, cos by sine. Secant is there, 1 by cos. Cosecant is there, 1 by sine. Like that. Start applying the ratios. So 1 plus 1 by cos A. What is the LCM? So I'm just dealing with this one. LCM is cos A. So this will become cos A plus 1 whole divided by 1 by cos A. So now I'm keeping cos A plus 1 divided by cos A as it is. If we shift this 1 by cos A to the top, it will become ulta. That is cos A by 1. Am I right? Cos A by 1. So it is in product format. Cos A will get cancelled with each other. So I got cos A plus 1 as the simplified version. Whereas RHS is, but the given RHS is sin square A divided by 1 minus cos A. So to get the equal terms, we have to solve the RHS also now. That is sin square A is nothing but what? Sines. We know one identity, sin square A plus cos square A is equal to 1. So sin square A is equal to 1 minus cos square A. Again, this is basic. So sin square A can be written as 1 minus cos square A. So 1 minus cos A. I am keeping the denominator as it is. So in RHS, 1 minus cos square A, it is in the format of 1 minus cos square A. It is in the format of A square minus B square, where A is equal to 1 and B is equal to cos A. So 1 square minus cos square A. That is nothing but 1 minus cos square A can be written as 1 plus cos A into 1 minus cos A. Okay. So numerator 1 minus cos square A can be written as 1 plus cos A into 1 minus cos A. If there is any issue in this simplification, watch it again or else decrease the watching speed and you will get a better idea. So 1 minus cos A, 1 minus cos A cancel with each other. So RHS is 1 plus cos A. So after simplifying both LHS and RHS, so this is second result. After simplifying LHS and RHS, I'm getting same result. See, LHS, after simplifying LHS, what happened? So you can see it over here. I got 1 plus cos A plus 1. After solving RHS, I got 1 plus cos A. So LHS is equal to RHS. So LHS is equal to RHS, that is equal to 1 plus cos A. Sometimes directly we get the RHS, but in some problems we have to solve both LHS and RHS in a proper way. Okay, let's take one more, fifth one. Again, this is bit lengthy one. So let me directly take the sixth one.